Hi guys, this is Mrs. Denton. Today we're going to do lesson 9-6, writing scientific notation. Grab you some notebook paper and let's get started. Make sure you're taking notes. Pause the video at any time if you want to try to solve any of the problems that we're going to work on together. Okay, for the warm-up, it says write the number in standard form. So this was a skill that we practiced yesterday. You can also use the yellow calculator if you have one like that to put these in and convert. Or you can simply just look at your exponent and decide right or left and move your decimal from there. So go ahead and pause the video and try these 6 warm-up. Okay, in number 1 we have 6 times 10 to the 3rd power. So we have a positive 3 exponent. That means we're going to be moving our decimal to the right, creating a larger number. If we have a whole number like 6 in the factor position, the decimal is understood to be at the end. So we would need to move that decimal 3 places over, fill in those spots with zeros, and create a new value of 6,000. Okay, number 2, we have a negative 4 exponent. That's telling us we need to move it to the left and create a smaller number than what we have here in the factor position. So again, we have a whole number 4, so we're going to put the decimal there at the end. And if you want to come right up here and put your 4 and move that 4 places, so that would include 1, 2, 3, 4. Put your new decimal there. We no longer need the old decimal. And you're going to fill in those spaces with zeros for placeholders. So this new value would look like 0.0004. Okay, number 3, we have a 5 in the exponent position. So we're going to move it to the right because it's a positive. Currently it's a whole number 2. So it would look like at the end of 2, move over 5 positions, fill in those with 5 zeros, go back through and put in that placeholder. So it looks like we have 200,000 for our final answer. Number 4, we have a negative 2 exponent. That tells us we're going to make it a smaller value. We're going to move to the left twice. Currently, it is 2.6. So when I move twice to the left and put my new decimal, I have 1 blank spot to fill in with a placeholder, get rid of that old decimal. So my new value would look like 26 10,000ths. I'm sorry, 26 thousandths. Okay, and number 5, we have a 10. We have 2 places that we need to move, so that tells us that we have 8 zeros that we need to fill in with. So 5, 2, 5, 1, 2, 3, 4, 5, 6, 7, 8. Come starting at the right, move 3 places over, put your comma, 3 places over, comma, 3 places over, comma. So there's your new value. Number 6, our exponent is negative 5. We're going to go to the left 5 places. So we need 1 place value, and then we're going to fill in with 4 zeros. Remember, you must include all digits when you're creating these numbers. You may also need a placeholder in the ones place, so fill that in with a 0. And there you go. Okay, a couple of things that we're going to talk about. Writing numbers in scientific notation. What's important? Well, step 1, move the decimal so that it is located to the right of the leading non-zero digit. Now, non-zero is important, so pay attention to that. Step 2, count the number of places you moved the decimal point. This indicates the exponent of the power of 10. So keep count when you're working with these. Numbers greater than or equal to 10. use a positive exponent when you move the decimal point to the left. The example has 8,600 or 8,600. We need to locate the decimal, or we need to position the decimal, I should say, in between the digits, the non-zero digits, so that it fits that criteria over here in the study tip. Remember that factor or first part must be greater than or equal to 1 and less than 10. Now this study tip also brings up an important part. If we're talking about a whole number and we want to write it as scientific notation, we can use a 0 as an exponent to show that it's equivalent to the same value. Say it were a whole number like 6, we can write that as 6 times 10 to the 0 power, because anything to the 0 power is 1, and 6 times 1 is 6. So let's go back over here now to writing 8,600 in scientific notation. So I'm going to place the decimal between the 8 and the 6 so that it fits the criteria greater than or equal to 1 and less than 10. That way I know 8 6/10 or 8.6 fits the criteria. Then I need to count that number of spaces because that value becomes my exponent for my power of 10. Okay, for numbers between 0 and 1, so those smaller decimal numbers, we're going to use a negative exponent when we move the decimal to the right. So key words here: number greater than or equal to 10, positive exponent, move the decimal to the left. Number between 0 and 1, negative exponent, move the decimal point to the right. So we're going to position our decimal so that it makes a value greater than or equal to 1 but less than 10 for my factor or first part. And then we're going to count the number of decimal places, and this is a smaller number, so pay attention. This new exponent must be a negative if it's a smaller number with your decimal and we're moving to the right. So you may want to come back to this key idea page as we work along here. Example 1 says writing large numbers in scientific notation. So if I were to write this number in scientific notation, it says Google purchased YouTube for, and let's talk about, this is my thousandths, this is my million, this is my billion. So Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. So we're going to change this over to scientific notation. Now, if I have all of these digits, I want to place my decimal in the location where it fits the criteria greater than or equal to 1 but less than 10. So it looks like I would put my decimal there, and I'm going to basically take every non-zero digit, that's going to be my first part or my factor, and just ask yourself as you're going along here, does this meet the criteria? Is this greater than or equal to 1 but less than 10? Yes. Okay. Then we're going to put our times sign. Then we're going to put our power of 10. Now this is where we need to count in order to make sure our exponent is correct. So if I've placed the decimal here, I need to count the number of spaces to the end so that I know my exponent is correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is a larger number, moving it to the right. So I'm going to have an exponent of 9. So this is what my scientific notation answer would look like. Now you try. Go ahead and pause the video and then you can come back and see if you have this one correct. Okay, so I have 2,450,000. I'm going to place that decimal in those non-zero digits. So that's going to be the first part of my scientific notation number. That's my factor. And then I'm going to count the number of spaces to make it back to its original form. And that number becomes my exponent for scientific notation. Okay, example 2. Now we're going to practice writing small numbers in scientific notation. So same concept, but we're going to be working with a negative exponent now. So let's talk about the 2004 Indonesian earthquake slowed the rotation of Earth, making the length of a day, and here we have this large number that's actually a small amount, second shorter. Write this number in scientific notation. So I am going to count 1, 2, 3, 4, 5. So I have 5 zeros after the decimal, and then 2, 6, 8. So I'm going to take just the non-zero digits, and I'm going to think about the placement for my decimal, where it would need to be located in order to be greater than or equal to 1 but less than 10. That now becomes my factor. And this is a smaller number, so my exponent is going to be negative, and I'm going to count the number of places. 1, 2, 3, 4, 5, 6. So we're going to have a negative 6 for our exponent. Okay, example 2 says, now you try. So write the number in scientific notation, and you can pause the video and then come back and check your work. Okay, number 1, I have the number 50,000. I'm going to focus on the non-zero digits. So 5, I can use that as my factor, and my exponent is going to go where my decimal is located at the end. 1, 2, 3, 4. So my exponent needs to be a 4. Okay, number 2, focus on the non-zero digits. Think about where you're going to place the decimal. So 2.5, that's your first part. And then count the number of places over. So 1, 2, 3, 4, 5, 6, 7. So we're going to have a power of 10 with a 7 exponent. Okay, number 3, there are no zeros. So focus on where you would place this one between the 6 and the 8. And think about the number of places to move. And it's to the right, so it is a positive 2. Number 4, focus on the non-zero. It's going to end up being a whole number. However, this one is a smaller number, so we're going to have a negative exponent. And if we were to put it at the end of 5 and then count over the number of places, it would be a negative 3 for our new exponent. Okay, same thing with number 5. Focus on the non-zero digits. Place the decimal where it needs to be to fit the criteria, and count over the number of places. So 1, 2, 3, 4, 5, 6, 7. Looks like we're going to have a negative 7 exponent. Okay, focus on the non-zero for number 6. Place your decimal to make it greater than or equal to 1 but less than 10. And then if you placed it there, count the number of places. 1, 2, 3, 4, and it is a negative, so making it a negative 4 exponent. Okay, example 3 says using scientific notation. So now we're going to actually apply it to a word problem. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive the award? Okay, the award is listed over here, and the award says that an album receives the award when it sells 10 million copies. So first of all, we need to find the difference. Currently, they've sold 8,780,000. So in your calculator, go ahead and put in 10 million and subtract 8,780,000. And that leaves us with 1,222,000 needed to sell. Our question says, how many more copies does it need to sell to receive the award? And if you'll notice, our answers are all written in scientific notation. So we are going to take this answer that we just calculated, and we're going to write it in scientific notation. So focus on, whoops, and I've made a mistake there. So my apologies. This should be a 0. I don't know why I wrote a 2. So focus on the non-zero digits. Think about where you're going to locate your decimal. And then put your power of 10, count the number of spaces, 1, 2, 3, 4, 5, 6, and that becomes your exponent. So it looks like C is the correct answer there. That matches up with our answer. Okay, next problem. Example 4, real-life application. The table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. Okay, notice they're all written in scientific notation, so Paleozoic, Cenozoic, Mesozoic. We're going to take those and compare them. So if I were looking at each one of these, and you can put each of these into your calculator, and I were to write that out, 5, 4, 2, and I have an exponent of 6, so after I move 2 places, then I need to add how many zeros? 6. So come back through here, put your commas in their location. That's what that would look like. Our next one has an exponent of 7. So I have 6, 5, 5. After I move these 2 places, then I need to add 5 zeros. Come back through here, put your commas in there where it's located. And the last one, we have an exponent of 8. So 2, 5, 1. After I move those 2 places, then I would need to add 6 zeros. And now we have those values written in standard form that we could compare easily. So looking at order the errors from earliest to most recent. So most recent would be the smallest amount. So it looks like earliest time period would be the greatest. So Paleozoic would be probably the earliest because we have 542 million. And then we have the Mesozoic, 251 million. And the most recent would be the Cenozoic. Now, when you look at these values, can you see the order with the exponent? So notice the exponent in those first 2 is the greater exponent, and then the order is the factor as well.